Welcome back to eCoreAcademy students. My name is Anita and today I'm bringing you a new Algebra 2 lesson, as you can see. Today we'll be transitioning into a new Algebra 2 unit. This is going to be our fourth unit in quadratics, which we have been going through in Algebra 2. As I've said before, you probably have seen quadratics in Algebra 1. This is just looking at quadratics in the lenses of a higher level math student. So as you can see, the lesson we're going to be doing today is factoring quadratic expressions. You've probably already done this in Algebra 1. You've most likely already done this in Algebra 1. It's one of the fundamental things they teach you in Algebra 1 when it comes to quadratic functions. Often they'll teach you how to factor a quadratic expression before they even teach you how to graph a quadratic function on the coordinate plane. So this is really fundamental quadratics unit stuff that we're going to be going over. It's okay if you don't remember how to do it because many of you have taken that year gap between Algebra 1 and Algebra 2 to do geometry. So this is just a review. This is part 1 and part 2 will be review of some key concepts. I'll be bringing up some vocab and some terms when it comes to factoring that you might have seen in Algebra 1, but you didn't really put a name to that term or that type of factoring. So we're putting names to different scenarios and identifying different scenarios and finding ways to do as much mental math as possible but still get the right answer. Okay, let's understand what factoring is and do problems along the way in this video. So we're going to be doing 3 problems together, 3 different common scenarios you'll be seeing. So this video is just an icebreaker for factoring quadratic expressions. Before I even get into the video, I would really appreciate it if you hit the like and subscribe buttons to support myself and AJ as teachers here at eCoreAcademy and so that you can join in on the student community of eCoreAcademy. Also hit the post notification bell and don't feel afraid to drop a comment down below. Lastly, our social medias are in the description box, so please use them to follow us on those platforms and share as much as you can. Okay, let's get right into the video. So what is factoring? This first slide is pretty much just reviewing the vocab, what it is, and things like that. Okay, so factoring. Factoring is rewriting an expression as a product of its factors. So with factoring, you're trying to find what to multiply together to get an expression. So an expression is pretty much an equation. If you think of an equation, I'm just going to give you an example of an equation. 4x plus 5 equals 20. So you have a variable in there. The goal of that equation is to find what the variable is equal to. An expression is just like an equation, except you don't have an equal sign. So instead of having 4x, what did I say? I'm going to say 4x plus 5 equals 20. That would be an equation. An expression would be 4x plus 5. You wouldn't have that equals 20. An expression, you don't have an equal sign. So you're finding what to multiply together to get an expression. So what does this mean? You'll be given a pretty complicated expression. With quadratics, you're going to have an x squared term in there. You're going to have a constant with an x term in there, and you're going to have just your average constant. You're going to have usually 3 terms. Those 3 terms are going to be broken down into usually 2 expressions that when multiplied together can equal that quadratic expression. And I'll show you what I mean as we go through these examples. Again, explaining this through words is a little bit difficult, but when we work through the examples, it'll probably jog your memory. It's like splitting an expression into a multiplication of simpler expressions. So let me show you exactly what that means. Well, we know multiplication is when we are multiplying one thing times another thing. That's basic. So let me show you a very, very easy example of this. So let's say our expression, let's just say it's x squared. So I'm just going to write x squared here. So let's say this is the expression. Factoring is trying to rewrite this expression. So rewrite an expression as a product of its factors. So factors, when it comes to multiplication, factors are 2 things you're multiplying together to get a product. In this case, we can think of x squared as the product. And to find its factors, we're pretty much trying to break it down. An analogy of this would be, for lack of a better example, think of when you're eating and your food goes into your stomach. Your gastric acid is breaking down that food so that your body can use all that food and break it down into a type of energy that the body can use. So in this case, we're breaking down these quadratic expressions into their factors. So usually 2 factors that when not necessarily always 2 factors, but usually 2 factors that when multiplied together will yield that quadratic expression. Think of it as simplification. You're trying to simplify stuff as much as possible. So let's go back to this x squared. So x squared is your product. How can we break this down? Well, x squared is pretty much 2x's multiplied together. So x squared is equal to x times x. What we can think of is that these two x's are the factors. You have two x's, when multiplied together yield the product, the x squared. So the x squared is like your quadratic expression, and these two x's right here are like the factors that you would multiply to get that quadratic expression. Again, this is like this is like your end product, and then what we're trying to do here is break it into its factors. So understand what these quadratic expressions are composed of. So if we look down here, greatest common factor, always look for the greatest common factor, also known as the GCF. It's the largest factor that all the numbers in a set share. So if you're given a set of numbers, let me give you an example right here. If we have the set of numbers 4, 12, and 20, and I asked you what the greatest common factor is. Well, we're trying to find the largest number that can divide into all these other numbers and yield an integer amount that cannot be further that you can't further GCF. So let me give you an example in this case. So 4's factors are 1 and 4 and 2 and 2. 12's factors are 1 and 12, 2 and 6, and 3 and 4. 20's factors are 1 and 20, 2 and 10, and 4 and 5. So when you consider these factors, you think, out of these set of numbers, what is the factor that each of these shares, and that is the largest factor that each of these shares. For example, all of these numbers in this set share the factor of 2. All of them can be divided by 2 and yield an integer amount. However, that's not the largest factor that they can all be divided by and still yield an integer amount. The largest factor they can all be divided by is 4. 4 divided by 4 is 1, 12 divided by 4 is 3, and 20 divided by 4 is 5. Now we have all prime numbers. These can't be GCF'd further. So I'm just going to write it over here. So the GCF of this set would be 4. And notice how 4 is a part of this set. So that can happen too. Sometimes the number that is the GCF is also part of the set. So that's just a refresher on greatest common factor, and that will be used in quadratic expressions, especially when we're trying to break down these quadratic expressions into their factors. Okay, so that is what factoring is. That's an overview, hopefully a review, hopefully it jogged your memory. So now let's get into some practice problems, 3 to be exact, where we will be going through these, and hopefully these practice problems will help you understand these concepts a bit better. Okay. So problem number 1 is factoring ax squared plus bx plus c. Notice how this is written like standard form, except we don't have the equals 0 or equals y or equals whatever. We just have that expression that represents standard form. So ax squared plus bx plus c when a is equal to positive or negative 1. So if you remember, a is the constant that goes in front of your x squared term. So these types of problems, this is really the first type of problem, the most common type and perhaps the easiest type. It's when your x is equal to positive or negative 1. So you might have a negative x squared plus bx plus c, or you might just have x squared plus bx plus c, and of course b and c are other constant values. So that's what we're going to be working with first in this example. So the problem we have is x squared minus 11x plus 30. This is a quadratic expression, and we need to factor this. So we need to break this down into its factors. What are in this case, two simpler expressions we can make that, when multiplied together, give us this quadratic expression? And the answer is x minus 5 times x minus 6. How do we get there is probably what you're asking yourself, especially if you don't remember this from Algebra 1. That's totally fine. Here's the solution pre-written for you. You can copy this down if you want. I'll give you a second, and then to the right, I will be doing the solution together. So we'll be walking through it together. So I'll give you a second to copy that down if you would like. Okay, so now let's continue and let's actually do this together. I'm pretty much going to be writing the exact same thing down, but as I talk, I might add additional notes and just explain it to you in a different way than whatever is conveyed here. So not much is conveyed just through the numbers, but I'll try to give you my best explanation. So I'm just going to rewrite this expression, this quadratic expression, x squared plus 11x plus 30. So our a term here is 1, our b term is positive 11, and sorry, I wrote plus 11x. This should be minus 11x here, And this should also be minus 11x. I'm sorry about that. That should be minus 11x. Okay, so x squared minus 11x plus 30. So what are we going to be doing first? Well, let's work backwards to forwards. So let's look at this 30 and let's break it. Let's see what factors it has. So the first factors it has is 1 and 30. That's pretty obvious. The next set of factors it has is 2 and 15. 2 times 15 is 30. The next set of factors it has is 3 and 10. And the final set of factors it has is 5 and 6. So it has 4 pairs of factors. Also, when you look over here at this x squared, remember how on the last slide I said x squared is equal to x times x? Well, in this case, what we can do is, because we know that we're going to get 2 sets of parentheses with values inside, we know that our starting term is going to be x. That's how it always works with these factoring. So we can always just write that in beforehand. So x and x. We already know that, because x times x has to give us our first term in our quadratic expression, and that's x squared. So x times x is x squared. So we already have half of this done. Now we just got to find out what we're going to be adding or subtracting in each of these parentheses. So how do we do that? Well, what we have to do is that we have to pick from this set of these four pairs of these 4 pairs. So what you do is you take your C term and you identify all of its factors. Then what you want to do is you want to look at each of these factors and see how, if they're manipulated, like added or subtracted. This is called the guess and check method. So you want to see if there's a way you can add them or subtract them or manipulate them in some way by using addition or subtraction so that you can get the B term. So what does this mean? What I'm asking is, are there a pair of factors right here that when added or subtracted or manipulated in a way that they're added or subtracted can equal negative 11? So they have to be added or subtracted to equal negative 11, and they have to be factors of 30. That is how you solve these kinds of quadratic expressions. So what do I mean by that? Well, let's look at our first set, 1 and 30. So let's say 30 is positive and 1 is also positive. So in these parentheses, what happens is your constant term, as in if you put 1 down here, will be multiplied by the x in the other set of parentheses. This x will be multiplied with the constant term that you put in this other set of parentheses, and then ultimately those will be added or subtracted together, and that's what will give you your bx, that whole term. Therefore, you need to see if these two added or subtracted can give you the B term. So is there any way that I can add or subtract 1 and 30 to get negative 11? Well, there isn't, because if I do 30 plus 1, I get 31. If I do 30 minus 1, I get 29. If I do negative 30 plus 1, I get negative 29. And if I do negative 30 minus 1, I get negative 31. So that does not work. None of those that I just listed equal negative 11. Let's look at the second one, 2 and 15. 15 plus 2 is 17. That's not negative 11. 15 minus 2 is 13, not negative 11. Negative 15 plus 2, negative 13, doesn't work. Negative 15 minus 2 is negative 17. That also doesn't work. So out of each of these pairs of factors, you have 4 different possibilities of the answers you can get. And you got to just mentally check them and see if they work or not. So that doesn't work either. So let's go to 3, 10. So 10 plus 3 is 13, not negative 11. 10 minus 3 is 7, not negative 11. Negative 10 plus 3 is negative 7, and negative 10 minus 3 is negative 13. None of those work either. So we have to see lastly if 5 and 6 work. If 5 and 6 don't work, then we would consider this quadratic expression as unfactorable. You can't factor it. So let's see if 5 and 6 work. Well, 5 plus 6 is 11. We are looking for negative 11, not 11, so don't get tricked. 5 minus 6 is equal to negative 1. That's not negative 11. Then we have negative 5 plus 6. That's equal to positive 1. That is not negative 11. However, negative 5 minus 6 is equal to negative 11, which is what we're looking for. So, and I wrote down here negative 5 minus 6 equals negative 1. That should be negative 11. My bad. Okay, so we figured that out. This works. This combination works because if we have a negative 5 and a negative 6, those two added together give us a negative 11, which is our B term. So they work. So what we do is we take one of these values. We can take this negative 5 and put it in our first set of parentheses, and then we can take this negative 6 and put it in our second set of parentheses, and that is how we get this answer. We factored this expression x squared minus 11x plus 30 as simple as possible, and we've broken it down into two factors, x minus 5 and x minus 5 times x minus 6. If you decide to multiply these out, you will see that it equals x squared minus 11 plus 30. If you want to pause the video and do that, go ahead, but I'm just telling you, you can check it that way, and you should get x squared minus 11x plus 30. Also, I want to point out that with this b term right here, this is probably the trickiest part of figuring these out. If you're looking at your factors like 5 and 6 here, your largest factor in this pair will always share the same sign as your b term. So because our b term is negative, it's negative 11, we should automatically know that the 6 is also going to be negative. That's just a rule of thumb that you should remember, and it's very important that you remember that because that will save a lot of time when you're trying to do all these combinations and see what works so that you can properly factor these quadratic expressions. Okay, so we're going to do problem 2. That took a bit longer because I explained it, but now it should be a faster process. Okay, so now we're going to be finding common factors. So what does this mean? So we're given this quadratic expression, 9x squared plus 9x minus 18, and we're told that I'm just going to give you the answer now. The answer is 9 times x minus 1 times x plus 2. Sorry, 9 times the quantity x minus 1 times the quantity x plus 2. How do we get there? Here is the solution pre-written for you. I'll give you a second to copy it down if you would like. Okay, so now let me explain how this is its own problem type. You can see, first of all, here, that A is not equal to positive or negative 1. So A, which is this 9 right here, it is not equal to positive or negative 1. That's the first difference. Also, you can see in the answer, we are used to these two factors that are separated by either a negative sign, that have a subtraction sign or positive sign in the parentheses, and we're used to only these two sets of parentheses. Now we've thrown this 9 in front into the mix, and that might confuse some of you. So what exactly does that mean, and how did we get there? So let me do it down here. Let's actually do the problem together, and maybe if I show you the problem, it'll help you understand it better. So 9x squared plus 9x minus 18. And I want to remind you that the whole concept of factoring is simplification, breaking something down into its simplest terms. So you're trying to expand it as much as possible. So if you look here, the A value is 9, the B value is 9, and the C value is negative 18. Remember when you're talking about the concept of GCF, greatest common factor. So think of these constants as a set. So think of them as 9, 9, I'm sorry, I just put them in parentheses, but this is a set, 9, 9, and negative 18. So in this set, do they share a common factor? Since x in this case is not positive or negative 1, we can say that. So do these share a common factor? Well, yes, they do. The common factor is 9. 9 goes into 9 once, 9 goes into 9 once, and then 9 goes into negative 18, and the answer would be negative 2 if you divided that. So what does that mean? Well, we can pretty much pull that 9 out of this quadratic expression to make it easier for us to factor it. If we get rid of the 9 in front of our x squared term, we can factor this just like we factored the one from the last problem. If we leave the 9 there, it kind of complicates things, and we'll be doing that in the next problem. But what you're trying to do is you're trying to get the A term to be equal to positive or negative 1. That will make life so much easier. You're trying to get your A term equal to 1. That will make your life so much easier because you can factor it as simply as possible, as normally as possible, in a way that you are most used to. So what we're going to do is we're going to be dividing 9 from each of these terms. So I'm just going to put 9 outside of these parentheses. 9x squared divided by 9 is just going to leave x squared by itself. 9x divided by 9 is going to leave x by itself, and then negative 18 divided by 9 is negative 2. So this just leaves negative 2. And if you distributed 9, then you would see that you get back to this 9x squared plus 9x minus 18. Now we can just factor this as normal because you see our A term is positive 1, so we can do it just like we did the last problem. So let's look at this negative 2, and let's think of 2, and let's break 2 into its factors. Well, 2 is a prime number, so its only factors are 1 and 2. So we got to somehow find a way to make 1 and 2 work so that we can factor this. or else this is not factorable. So we need to find a way to add or subtract 1 and 2 so that it equals 1, because our b term in this case is 1, because plus x, we can assume that there's just an imaginary 1 here. So we need to find a way to subtract or add 1 and 2 to get 1. So how would we do that? Well, let's think about it this way. Let's start with -2. So -2 minus 1 is -3. So we can't make both of them negative. -2 plus 1 is equal to -1. -1 is not equal to 1, so that doesn't work either. How about 2 plus 1 if we make both of them positive? Well, that equals 3. That doesn't work. So our last choice is to make 2 positive and 1 negative. 2 minus 1 is 1, which is what we're looking for. So that's what we would do. So let me just write it down here. We did 2 minus 1 equals 1. So 2 would be positive, 1 would be negative. So how would we break that down? Well, we have that 9. Remember, don't forget that 9. Then we have the x, because remember, we're splitting x squared into x plus or minus a quantity times x plus or minus a quantity, so x. And then we can let's just throw -1 into the first set of parentheses, and then we can do that same x, but then we're throwing +2 into the second set of parentheses. And that would be our answer. If you multiply this out, you should get 9x squared plus 9x minus 18. And you can see that we simplified this. We factored it as much as possible. And that's how you would factor a problem like a quadratic expression like this, where your x is not equal to positive or -1, but you can find a GCF. That'll make your life so much easier when factoring. Okay, last problem, problem 3, probably the hardest problem we're going to be doing, factoring ax squared plus bx plus c when the absolute value of a is not equal to 1. So what does this mean? Well, this pretty much means that a is not going to be equal to positive or -1, and this is going to be intentional. Not like the last problem where we did GCF and we got rid of the 9 and then a became 1. In this case, we're intentionally doing that. So there's no way that you can GCF that a value out of there to get a equal to positive or -1. In this case, a is going to be 2 or -4 or 50 or -100, whatever. But the quadratic expression is going to be structured in a way that you can't GCF that out. You need to work with an a term that is not equal to positive or -1, and it changes up the process a little bit. So here's the problem: 4x squared minus 4x minus 3. You can already see that with the -3, you cannot factor the 4 out of there. So you need to work with the 4 in front of the x squared. And your answer would be 2x plus 1 times 2x minus 3. You're probably wondering, how did we get there? And we are going to be answering that question now. How do we get there? So here is the solution pre-written for you. I'll give you a second to copy it down. I know there's a lot of brackets, a lot of numbers, and it looks a bit confusing, but don't worry, I'll explain it. Okay, hopefully you got a chance to pause the video. I'm just going to continue and explain this. So let me first write this down: 4x squared minus 4x minus 3. So what do we want to do first? Well, we want to look at this 4x squared term, and we want to do exactly what we did with the c term. We want to see how can we break this 4x squared term, and we got to look mainly at the a term, so 4. What are the factors of 4? Well, factors of 4 are 1 and 4 and 2 and 2. So in our parentheses, instead of what we had x plus some value plus or minus some value times x plus or minus some value, that's what we've been working with so far. In this case, we're either going to have 2x and 2x as our first values, or we're going to have 4x and just x, because it's just one x. And these multiplied together give us 4x squared, and these multiplied together give us 4x squared as well. So the first value in each set of parentheses, when you multiply them, they should give you the first value of the quadratic expression. And that works for these two. But what we need to understand is which pair do we use and how do we use it. So now we got to come over to this -3, and let's look at 3. Ignore the negative sign for now. So -3. So which factors of -3 get us to -4? So let's just write. We know that the factors of -3 are 1 and 3. So these two factors need to be manipulated in a way that when added or subtracted are equal to -4, but when multiplied are equal to -3. That's a key point that I forgot to mention. These two factors that these two numbers that you find right here, that you add to the end of the values in the parentheses, when added together, they need to equal the b value, but when multiplied together, they need to equal the c value. And that's why we call them the factors, because we are breaking down this c value, which is the product, into its factors. So that should be a given. Next, we need to see how we can combine 1, 3 with 2x and 2x, or 4x and x. So this is where the guess and check method comes into play. So let's start off with 4x and x. I'm just gonna do mental math with all of you. So if we had 4x and x and we had 1 and 3, we're mainly focusing on the middle term, which is -4x. So if I had 4x in one set of parentheses and 3 in the other set of parentheses, I'm multiplying to get them together. If I have 4x in one set of parentheses, but I also have 3 in that set of parentheses, I'm not multiplying them together. So what happens is the two terms that you want to multiply have to be separated. So let's look at it this way. Let's say we have 4x plus 1 times x plus 3. So does this equal, when we combine these terms, does this equal -4? Well, 4x times 3 from the other set of parentheses is 12x. X times 1 is just x. That would, when we add 12x and x together, we get 13x, and that's not what we're looking for. Well, how about if we try this combination? We do 4x plus 3 times x plus 1. So 4x times 1 is 4x. Then we have the 3 times x, which is 3x. So 4x plus 3x is equal to 7x. That is not -4x. That also doesn't work. How about if we make them negative? So what I'm trying to get at here is that you're just putting these different combinations together. You're trying to see what works. You're trying to see, does one of them have to be negative? Does one of them have to be positive? And you're trying to just manipulate them in a way so that it works. And I know it might seem like a long and arduous process right now, especially with the guess and check method, but trust me, when you get a hang of it, you will be able to do these problems even when the absolute value of a is not equal to 1. You'll be able to do these problems very quickly. So I'm just going to tell you right now that 4x and x do not work. There's no way that you can combine them with 1 and 3, whether you make 1 and 3 positive or negative. There's no way that this works. So I'm just going to tell you that this is out of the picture, and by doing mental math or writing it down, you would have figured that out in time. So we have to find a way to make 2x and 2x work. So how exactly does this work? Well, let's look at the -4. Remember how I said that out of the factors, the larger factor has to share the same sign as the b value, which means 3 should share the same sign as -4. So this should technically be -3. So we already know that 2x, so we already know 2x and 2x. They're both the exact same value. So it doesn't matter in which set of parentheses we put the 1 and which set of parentheses we put the -3. So if we have 2x and -3, 2x times -3 is equal to -6x. Well, that's 2 away from -4x. So -6, let me write it up here. -6 plus this unknown value of x equals -4. So we know the difference between them, so -6 plus 4 is 2, is positive 2. So is there a way that we can get positive 2x with 2x and 1? There is. If we just multiply 2x and 1, we get positive 2x. Therefore, combining all of this together, you should be able to come to the answer of 2x plus 1 times 2x minus 3. And we just pretty much applied common sense and number sense, and just how can we manipulate, the key word is how can we manipulate these numbers and things like that, so that we can factor these quadratic expressions, especially when the absolute value of a is not equal to 1. The reason I show you the guess and check method is because that's the method that I've always been taught with, so I feel like that is my go-to method, and I feel like if you get the hang of it, if you get really good number sense, you're able to factor things in your head and add and multiply and manipulate those numbers in your head, you'll be good to go. So my advice is to use this method. If you're learning a different method in school, especially if you don't attend school in the United States, go with that. This was just meant to refresh you on factoring quadratic expressions so that we can apply this concept and just keep going in quadratics, because it's going to appear over and over again, and it's especially important when you don't have use of your calculator. Okay, so that's all I have for you today. I hope you enjoyed the video, and I hope it was a good way to jog your memory of quadratic expressions. We'll be continuing with part 2 and part 3. This is really just a review of Algebra 2 concepts, but I'm trying to go through them as fast as possible. So I would really appreciate it if you liked the video and subscribe to the channel if you haven't already. Please hit the post notification button and don't feel afraid to drop a comment down below. Please also use our social media in the description box, Facebook, Twitter, and Instagram, so that you can see all of our posts. You'll be notified of our latest posts, but you'll also have a tool to share with friends and family. If you have any personal or business concerns, please email us at our Gmail, which is eCoreAcademy@gmail.com. We really appreciate messages from people who are trying to help us out and spread the word about eCoreAcademy so that we can better the student community, especially during this global pandemic. Lastly, we have a website coming out. I know I keep repeating this, but it's actually out right now. We are populating it with content. Courses are arranged for you to follow in a way that YouTube doesn't let us arrange them for you. Also, you have access to notes, to quizzes, and to all those other things. You'll also have access to all of these videos. So I highly suggest you go. It's all free resources. So you just have to log in and you'll have access to this plethora of knowledge. That's all I have for you today. I hope you enjoyed the video. Please check out the website, and I'll see you in Factoring Quadratic Expressions Part 2. Bye.